I've reported on natural disasters across the world, but there's something about La Palma that stays with me. Maybe it's the silence. Maybe it's the way the island looks calm even when it's not. Or maybe it's because every scientist I spoke to there seemed to choose their words with more care than usual, as if speaking too confidently about Cumbre Vieja might wake something they'd rather leave undisturbed. When Cumbre Vieja erupted in 2021, most people thought the story ended when the lava stopped. Houses destroyed, thousands displaced, an island forever reshaped. But the scientists didn't see an ending. They saw a beginning. They said the eruption was part of a longer cycle, a pulse rather than a conclusion. And in the months that followed, I started to understand why some of them are quietly worried today. The island didn't settle, not completely, not the way a dormant volcano should. I remember sitting with a volcanologist in a small cafe overlooking the western slope. He was exhausted, sipping a cortado like it was the only thing keeping him upright. He told me the eruption had changed the internal plumbing of the mountain. Magma pathways shifted, pressure zones rearranged, gases migrated to places they hadn't before. He said almost in a whisper, "Cumbre Vieja isn't stable, it's reorganizing itself." It wasn't the words that unnerved me. It was the way he stared at the ridge as he said them, like someone watching a sleeping animal that could wake up angry. Since the eruption, monitoring stations recorded inflation beneath the volcano, subtle, slow, but persistent. Ground surfaces rising by millimeters, gas output fluctuating. Seismic activity spiking and settling in unpredictable waves. When I asked another scientist what the inflation meant, he said, "Pressure. Not enough to erupt right now, but enough to remind us that the magma chamber didn't empty in 2021. Not even close." He told me the deeper reservoirs beneath La Palma are still active, still feeding heat and gas upward. "Think of the volcano like a wound," he said. "The surface healed, the inside hasn't." What makes this place so unsettling is its history. Cumbre Vieja isn't a volcano that sleeps for hundreds of years at a time. It erupts repeatedly, 1949, 1971, 2021, with gaps that are short, geologically speaking. And each eruption teaches scientists something new about how unpredictable this system can be. The 1949 eruption, for example, caused a dramatic fracture along the volcano's spine, a long tear that opened suddenly and violently. The western flank, the enormous section of the island that slopes toward the Atlantic, shifted by several meters. Even today, you can stand on the ridge and feel the presence of that ancient wound beneath your feet. When researchers study that fracture now, they don't talk in absolutes, they talk in probabilities, in scenarios, in ranges. But one scenario comes up again and again. The possibility, however unlikely, that a future eruption could destabilize the flank even further. When I asked a geophysicist about this, he didn't give me an alarmist answer. He gave me a measured one, the kind you only hear from people who've spent decades thinking about the same problem. Cumbre Vieja is a layered system, he said. Lava, ash, brittle rock, old fault lines. It's stable right now, but stability isn't permanent under enough pressure. Anything can fail. I pressed him on what failure meant in this context. He didn't explain it immediately. He placed his coffee cup on the table, aligned it perfectly, and looked at me like he was weighing how honest he should be. Then he said, "The western flank is heavy, steep, saturated. If a major eruption occurred in the right place, or if magma intruded along the wrong fracture line, we could see a significant landslide." He didn't say the word most people think of. I had to ask him myself. "A collapse?" He exhaled before answering. "A partial collapse, yes. The full scenario, the one documentaries love to dramatize, is extremely unlikely, but a partial collapse is within the realm of physics." I remember the way the cafe seemed to quiet around us after he said that, because even a partial collapse would be catastrophic. A collapse into the sea could trigger a local tsunami that would hit other Canary Islands quickly. Larger scale scenarios are still debated fiercely among scientists, but the point is, the risk isn't zero, and the idea that pressure is rebuilding beneath a volcano with that kind of geological past is enough to make any expert uneasy. But the scientists on La Palma aren't nervous about one dramatic event. Their concern is the trend, the inflation, the gas spikes, the strange, restless seismic whispers deep beneath the island. The sense that Cumbre Vieja hasn't settled into dormancy. It's adjusting, shifting, breathing. One researcher compared the volcano to a heavy door with a faulty hinge. It might hold for decades, she said, or it might give way suddenly. Without warning, our job is to measure how strained the hinge is. Walking the lava fields from 2021, it's hard to imagine that something so still could hold that kind of danger. The ground feels solid beneath your feet, black, sharp, cold. But beneath that crust is a heat signature that still glows on satellite instruments, magma pathways that still pulse with movement. During my time on the island, I met residents who rebuilt their homes, farmers who returned to what was left of their land, families who started again on a surface that didn't exist 2 years ago. They talk about the eruption like a memory they survived and moved beyond. But the scientists don't talk that way. For them, 2021 wasn't a traumatic event. It was data, a message from the volcano. And the message wasn't, "I'm finished." The message was, "I'm not done." That's why they watch every tremor, every millimeter of uplift, every gas plume that rises from cracks still steaming in the earth. They're not panicking. They're preparing. In the months following the 2021 eruption, the world moved on. Tourists returned to La Palma. Lava fields cooled and were photographed for postcards. Local authorities touted rebuilding successes. But the scientists didn't move on. I spent weeks following them, tracking their daily measurements, sitting in small monitoring stations tucked into the hills, and reviewing data that the public rarely sees. What became clear is this: Cumbre Vieja is not resting. Not in any sense that we could call normal ground deformation is accelerating. Since the last eruption, GPS stations have recorded several centimeters of uplift in areas that were previously considered stable. That doesn't sound like much to the casual observer, but to volcanologists, it's a glaring warning light. Each millimeter represents magma or superheated fluids moving beneath the surface. And when movement is uneven, the risk of a flank failure increases. Seismic activity is another concern. In the weeks before my arrival, scientists reported swarms of deep earthquakes, many too faint to feel, but detectable with sensitive instruments. They appear in patterns, bursts of tremors along hidden faults beneath the western flank. One seismologist showed me a chart, hundreds of tiny quakes in clusters, some lasting mere minutes. He described it as the volcano breathing, a metaphor that sounds poetic until you understand that each breath carries pressure. Gas emissions are spiking unpredictably. Carbon dioxide and sulfur dioxide levels have risen in areas previously quiet. One researcher explained that CO2 can seep through fractures and accumulate beneath the soil. When concentrations reach critical levels, they can trigger sudden eruptions or destabilize rock layers. Scientists are calling it a subtle but serious warning signal. The local authorities share some of these readings, but not all. They focus on safe zones, hazard maps, and evacuation routes. But internally, the scientists are watching more than maps. They are watching numbers that could hint at catastrophic behavior. Long before anyone outside the research community notices, I remember standing with one volcanologist on a ridge overlooking the western slope. He traced a finger along a map of the underground magma chamber, layers in red and orange, fractures in white. His voice was calm, almost casual, but every sentence carried weight. If magma intrudes in the wrong location, he said, it could pressurize the western flank. And if that flank gives way, he paused. The unspoken words hung in the air. Landslide, partial collapse, tsunami, cities in the Atlantic at risk. And though the probability is debated, it's not zero. Not for scientists who have seen the evidence firsthand. Volcanic systems like Cumbre Vieja rarely announce major changes in ways humans can perceive. The magma moves slowly, sometimes millimeter by millimeter. Gas leaks silently. Cracks expand imperceptibly. And yet beneath the surface, pressure accumulates relentlessly. I reviewed satellite imagery from European Space Agency missions. Even the casual observer can detect subtle uplift, but the specialists see patterns that are far more concerning. Localized bulges in the western flank, new fissures forming along older fractures, repeated micro-seismic swarms at depths of 5 to 10 kilometers. One scientist described the imagery as the volcano rearranging itself, getting ready, testing its own limits. I spoke with a geophysicist who had spent decades studying flank collapses on oceanic volcanoes. He showed me models suggesting that a partial collapse of Cumbre Vieja's western slope could displace billions of tons of rock into the Atlantic. His hand hovered over a map, tracing the projected tsunami path. Small islands in the Canaries, parts of the African coast, even the eastern seaboard of the Americas could, in theory, feel waves if the collapse were large enough. The conversation was clinical, full of caveats and probabilities, but the undercurrent was unmistakable. This volcano is alive, and it is capable of shaping coastlines and human lives in ways most people don't consider. I asked why more attention hasn't been given internationally. The answer was simple: uncertainty. Scientists cannot predict exactly when an eruption will occur, nor whether a collapse will happen. Models can give ranges, probabilities, and potential impacts, but not certainty. And governments are cautious about spreading panic based on probabilities rather than facts. Yet the concern among the volcanology community is palpable. Meetings that are officially routine often end in private discussions about worst-case scenarios. Reports circulate internally about deformation rates that are unprecedented in the modern observation period. Data streams from ground-based sensors are scrutinized hour by hour, and although the public sees only the lava flows of 2021, the real story is underground, invisible, and slowly escalating. Some scientists have begun calling it a pressure anomaly, small, gradual, consistent enough to keep them awake at night, enough to prompt them to monitor the volcano with more intensity than ever before. I saw firsthand the tension in their offices, researchers double-checking measurements, graphs on screens that glow in dim light, alerts that sound quietly in the background, and every so often one of them mutters a number: millimeters of uplift, parts per million of gas, micro-seismic energy, enough to make anyone outside the field uneasy. And then there's the human factor. The island's population is growing. Infrastructure has been rebuilt since the 2021 eruption, sometimes over unstable ground. Roads, bridges, and settlements sit above potential magma chambers or fracture lines. Every measurement indicating increased pressure or flank instability becomes not just a scientific concern, but a public safety challenge of unimaginable scale. The scientist I shadowed didn't exaggerate. He didn't dramatize, he simply repeated the numbers, the data, the probabilities. And when he did, the story became clear. Cumbre Vieja is not sleeping, it is reorganizing. The pressure is increasing, and the mountain is testing its own limits quietly, deliberately, far below the surface where no casual observer can see. If the trends continue, if uplift persists, if gas and seismic activity spike simultaneously, the worst-case scenarios we read about in textbooks are no longer theoretical. They become plausible. And plausible is enough to make the scientists who live and breathe these measurements uneasy. This is why they are panicking. Not openly, not in headlines, but in their own way, with nightly monitoring, constant data review, and careful modeling. They are watching a natural system that is slowly reminding humanity of the power of forces we cannot control. And that is the story the world has yet to grasp. The danger is quiet, invisible, and escalating beneath the ridge of La Palma. When you ask scientists what an eruption at Cumbre Vieja might look like in the future, they hesitate. Not because they don't know, but because they know too much. They've seen the models, analyzed past eruptions, and watched the volcano reshape itself in ways that defy easy prediction. But over time, through dozens of interviews, a pattern began to emerge. Each expert, no matter their speciality, geophysics, gas chemistry, seismology, described the same sequence of events: a chain reaction, a timeline that starts quietly and grows into something the island is not fully prepared for. It usually begins with deep seismic unrest, earthquakes too faint for residents to feel, occurring miles beneath the island at the boundary where magma begins its ascent. Clusters of them, rapid and concentrated, sometimes in streaks that stretch across the ridge like threads pulled tight. To the untrained eye, these tremors mean nothing. To the scientists, they mean pressure is building again. The next stage is gas release. Magma heating the rock above it forces carbon dioxide and sulfur dioxide toward the surface. Monitoring stations detect sudden spikes. Trees near vents wilt. Small animals behave strangely. Some areas develop a faint acidic smell, so subtle that only people who lived through the last eruption recognize it. Then comes ground deformation. The uplift accelerates, not millimeters per month, but per week. One volcanologist described it as watching a balloon inflate beneath the island. That's when we get nervous, when she told me. Not the tremors, not the gas, the uplift. Because uplift means volume, and volume means the intruding magma is looking for a way out. The first visible signs arrive slowly: steam from old vents, cracks widening along roads built over ancient lava tubes, hot spots detected by satellites where there were none just days earlier. To residents, it looks like inconvenience. To scientists, it looks like alignment, the magma working its way toward a rupture point. By now, emergency officials begin quiet preparations. Evacuation routes are checked. Shelters are restocked. Helicopters run test flights. Nothing public, not yet, but the island's emergency heartbeat begins to quicken. Then, inevitably, the tremors rise to the surface. Instead of deep quakes kilometers below, the island shakes with shallow seismicity, the kind people feel under their feet. A rumble, a jolt, windows rattling. The last time this happened, the 2021 eruption, began within days. Scientists fear the next time could be faster. If magma reaches the surface on the western flank, the eruption could follow a pattern similar to past events. Long fissures opening suddenly, fountains of lava spraying tens of meters into the sky, and high-speed rivers of molten rock racing downslope toward the ocean. That alone would be devastating. Entire neighborhoods rebuilt after 2021 could be buried again. But that's not the scenario scientists fear most. The real fear lies deeper, beneath the ridge. Along the fracture line left behind in the 1949 eruption, if magma begins intruding into that old weakness, pressurizing it, widening it, destabilizing the massive rock slab that forms the western flank, then the situation changes completely. When you ask scientists what an eruption at Cumbre Vieja might look like in the future, they hesitate. Not because they don't know, but because they know too much. They've seen the models, analyzed past eruptions, and watched the volcano reshape itself in ways that defy easy prediction. But over time, through dozens of interviews, a pattern began to emerge. Each expert, no matter their speciality, geophysics, gas chemistry, seismology, described the same sequence of events: a chain reaction, a timeline that starts quietly and grows into something the island is not fully prepared for. It usually begins with deep seismic unrest, earthquakes too faint for residents to feel, occurring miles beneath the island at the boundary where magma begins its ascent. Clusters of them, rapid and concentrated, sometimes in streaks that stretch across the ridge like threads pulled tight. To the untrained eye, these tremors mean nothing. To the scientists, they mean pressure is building again. The next stage is gas release. Magma heating the rock above it forces carbon dioxide and sulfur dioxide toward the surface. Monitoring stations detect sudden spikes. Trees near vents wilt. Small animals behave strangely. Some areas develop a faint acidic smell, so subtle that only people who lived through the last eruption recognize it. Then comes ground deformation. The uplift accelerates, not millimeters per month, but per week. One volcanologist described it as watching a balloon inflate beneath the island. That's when we get nervous, when she told me. Not the tremors, not the gas, the uplift. Because uplift means volume, and volume means the intruding magma is looking for a way out. The first visible signs arrive slowly: steam from old vents, cracks widening along roads built over ancient lava tubes, hot spots detected by satellites where there were none just days earlier. To residents, it looks like inconvenience. To scientists, it looks like alignment, the magma working its way toward a rupture point. By now, emergency officials begin quiet preparations. Evacuation routes are checked. Shelters are restocked. Helicopters run test flights. Nothing public, not yet, but the island's emergency heartbeat begins to quicken. Then, inevitably, the tremors rise to the surface. Instead of deep quakes kilometers below, the island shakes with shallow seismicity, the kind people feel under their feet. A rumble, a jolt, windows rattling. The last time this happened, the 2021 eruption, began within days. Scientists fear the next time could be faster. If magma reaches the surface on the western flank, the eruption could follow a pattern similar to past events. Long fissures opening suddenly, fountains of lava spraying tens of meters into the sky, and high-speed rivers of molten rock racing downslope toward the ocean. That alone would be devastating. Entire neighborhoods rebuilt after 2021 could be buried again. But that's not the scenario scientists fear most. The real fear lies deeper, beneath the ridge. Along the fracture line left behind in the 1949 eruption, if magma begins intruding into that old weakness, pressurizing it, widening it, destabilizing the massive rock slab that forms the western flank, then the situation changes completely. This is where scientists grow quiet, where the tone in their voice shifts, where every phrase becomes carefully measured. Because if that flank begins to slip again, even by a few meters, it could trigger a partial collapse into the Atlantic. Not the apocalyptic mega tsunami that popular documentaries once dramatized. No scientist endorses that narrative anymore. But even a moderate collapse, just a fraction of the total mass, would create enormous waves enough to damage ports, enough to flood coastal areas across nearby islands, enough to put emergency services into chaos. One geophysicist walked me through the scenario step by step first, a violent blast of steam and ash, then rapid fracturing along the ridge, next a sudden downslope movement, slow at first, then accelerating rock the size of office buildings breaking free, a thunderous slide into the sea. He told me the resulting wave would hit La Palma's western coast in minutes, giving residents little time to react. Ports could be destroyed. Low-lying roads wiped out, boats tossed inland like toys. From there, the waves would radiate outward across the Atlantic, reduced in power, yes, but still fast, still dangerous. Civil protection agencies across the region model this scenario routinely. Though they rarely discuss it publicly, the probabilities remain low. But the consequences, if it happened, would be severe enough that they cannot ignore it. Back on the ridge, I watched scientists refresh their screens. Live feeds of seismic graphs, gas charts, deformation plots glowing in the dim light. These charts tell a story that is still being written below the ground. One afternoon, a sudden swarm of small quakes appeared dozens in minutes. The room tensed. No alarms, no shouting, just a quiet, collective stillness. Then the swarm stopped. Just as suddenly as it began, everyone relaxed, but only a little. That, one of them said, is what we expect more of before the next eruption. He meant volatility. He meant unpredictability. He meant signals that seem like warnings, but aren't. Until one day, they are. And there is something else, a detail almost no one outside the scientific community talks about. Beneath the island are multiple magma reservoirs, layered like a staircase descending into the earth. Some are shallow and quick to erupt, others are deep, older, more volatile. The concern is not one reservoir waking up, it's several waking up together. This phenomenon is called multi-level activation, and when it happens, eruptions can be larger, more destructive, and more chaotic than typical lava flows. One researcher described it perfectly. When multiple reservoirs recharge at once, the volcano behaves like it's angry, and the signs, however subtle, suggest that Cumbre Vieja might be entering that kind of reactivation cycle. As I left the monitoring station each night, I felt the weight of what I'd heard. Not fear, not panic, but respect. Respect for a mountain that has shaped this island for thousands of years. Respect for the scientists who watch it, measure it, lose sleep over it. Respect for the delicate balance beneath the ground. a balance that, one day, will shift again. And when it does, the world will remember that Cumbre Vieja is not a quiet ridge. It is a volcano, a living system, one that is reminding us, slowly and steadily, that it is not done.